Welcome to InnoBuzz Java Video Tutorial Part 8. This chapter contains knowledge on collections. The collections are some kind of containers that group elements into a single unit. So they contain multiple elements. We have already met them, like arrays and the stack that we have seen. These collections will help us to use our variables more easier and reach them and faster. At the end of this chapter, we get a very useful knowledge about how to attend a same type of objects group. Let's see the overview of this chapter. We are going to see what is exactly the collection's purpose, how we can declare and use a very simple general type of collection. We will see the building of the collections class hierarchy. We will see the classes under list and their usage. We will see the classes under the interface set and how to use them, and also the interface map. These are the three most important interfaces under collections. At the end, we will talk about the collection utility class as well. So far, we have seen and talked about some collections, for example, the arrays, and I've also shown a stack in one of our programs. The collections are some kind of container objects that collect the same kind of objects together in some kind of representation where we can reach them, we can use them, change them, and so on and so on. In Java language, there is a whole framework built on these collections that we can use. This is called the Java Collection Framework. This is a big part of Java language, only created for these purposes. So what do we have in our collection framework? We have got interfaces. Interfaces that are abstract data types that could represent the collections. Of course, we have to implement these interfaces if we want to use them, and this way we can form a hierarchy as well through the interfaces, and there is also a possibility to create some kind of abstract execution. This means that we can create abstract classes that implement these interfaces, so this way we don't have to implement all the abstract methods. Some of them can remain abstract in our abstract classes if we want to create some user-defined collections. There are also some immediately utilizable classes. These are the implementations of these interfaces that we can use, the concrete implementations. These are the reusable and utilizable data structures that we are going to see, and there are some classes that are very frequently used. And the assistant methods, these are the algorithms. Using them we can perform computations like searching or sorting on the objects that are in our collections. These algorithms are so-called polymorphic algorithms. So they can be used to many different implementations of the same collection interface. Why is it good to use the Java collection framework? Well, when we are writing programs, it is a good benefit that, for example, we can use program parts that are already written and we don't have to write these important data structures and algorithms that are very common to use in our programs, and it is already written there, so we don't have to create them. And it is also important that the implementation of these collections and collection classes is very high performance, so they can do very quickly their job and very well. So in fact, this is much more easy to use them, and most programmers use these because they work very well. And it is also important that if we use these, then other programmers can use our program codes easier because they use the same classes as well, probably. And we can also probably use their codes because they are going to use these as well. So to read and to change codes of each other and exchange codes between each other it makes much better, much easier. Let's see now how the Java collection hierarchy looks like. This hierarchy belongs to the Java collections framework. There are some very important interfaces that belong to this hierarchy that are the top of it, and we can implement the classes, and there are also implemented classes that are belonging to these interfaces. All of them is in the java.util package. The top of this hierarchy, there are two important interfaces, the collection and the map. The collection represents a group of objects. All objects are called elements. So this only means that we have a group of elements. There can be different kind of collections. There can be ordered and unordered. Some of them allow duplicate elements, others do not, and so on and so on. We will see that in details. The map interface is named after mapping keys to values. So classes that implement this will have two important parts, the keys and the values. Now let's see what's inside them. Some of the most important sub-interfaces is the set and the list. The set cannot contain duplicate elements. The list is an ordered collection which can contain duplicate elements. We will see them and talk about them. There is a very important interface, sub-interface of map, the sorted map, which does the mapping and also the elements are sorted. The list has some very important classes that we are going to see, the array list, the vector, the linked list, and for example the stack is the child class of vector that I have shown in the previous chapter. The hash set, the tree set, the linked hash set belong to the set. So they implement these interfaces. The rounded brackets are the interfaces, always. The tree map hash table and hash map implement the map and the sorted map interfaces. We will see these in details in the next slides. So this is of course only a part of the collection hierarchy. These are the important interfaces and classes that we are going to talk about in details. So we can see the connection between them and how they implement and extend each other. Let us talk about the list now a little bit and the classes that are going to be under it, so which are implementing the list interface. The list is the subinterface of collection, and we can put duplicate elements into lists. And of course, as it is a subinterface, it has all the methods inherited from collections, but there are some additional things. For example, the search. We have to implement the search if we want to implement the list. So we can search a specified object in the list and get the position. And also, if we have the position, we can access the members, for example. Now let's see what we have got here. The important implementing classes. The linked list, the array list, the vector, which is the parent of the stack, and the abstract list. Linked lists and array lists are alternatives to each other. While an array list uses an array internally to store the data, of course it's a dynamical array, so we can change the size of it, but it's still some kind of array. A linked list uses nodes to hold the elements. These nodes then point to each other. That's why we call it linked list. So the two lists are a little bit similar to each other, but they are working differently. Well, the vector is in fact a little bit similar to the array list, as they are both index based and backed up by an array internally. Both of them maintain the insertion order of an element. So this means that we can get our objects in the order that we have inserted them. Both of them allows us null and duplicate elements as well. So they are a little bit similar, but there are some cases that they are different. There are synchronization, thread safety, speed and performance, things that they are different in. For example, the vector is a synchronized class, so it can be used in multi-threaded situations that we are going to talk about a few chapters later. And the array list cannot be used here. But for example, in speed and performance, the array list is faster. So if we go in smaller details, we can see that there are differences. Nowadays, in most of the desktop applications, the most popular is the array list. So this is some kind of dynamic array, which the size can be changed dynamically, as I've already told. There's one more important thing about lists that I mentioned here, is the generic class. But in fact, this is true for all the collections that we were talking about. So the collections are generic interfaces. So this means that when we declare the objects that belong to classes that implement these interfaces, the collections, we can specify the object type, and these are generics. So this means that I can put in this list the specified type of object, the specified class. We can tell the Java compiler that what kind of elements will these contain. This is very useful. So we don't have to make typecasts, and we don't have to check if we have the correct type and things like that. I'm going to show it in practice. We are here again in our test project, and we are going to make some practice on the lists now. But we have already done it so far because we in the previous demos we used this stack, and it is also uh, in java.util, and this implements also the list, but this time I'm going to use the array list. So I put a star here so I can use anything from java.util, and we are going to create an array list. Well, let's say list. So I use the interface as a type, and this is the generic specification that I use here because I'm going to put some strings here. String first. Well, we can say that animals or something. This is a new array list, and we also have to specify the type here. So this is going to contain strings. From now on I can use this. I can use it like animals dot, and we can see the methods that I can use. We were talking about them in the slides as well. It is empty, last index of, and contains, for example, object. And of course, if I use it here, this will also use the string because we already gave the string type as a generic. Remove all, set, sublist. We can make an array out of it. So lots of things, but what we use here is add, and I add a string, something like elephant, and things like that. Well, we say lion, we say zebra, we say, I don't know, crocodile. Okay, I added them, and I just print it. For example, I simply print like the whole animals. Well, I save it and run. Elephant, lion, zebra, crocodile. This is an array representation. I can see the other things as well that I don't really need at the moment. But what I really wanted to show that we can use this of course with, for example, I can give here the person as well. So if I put the person interface as a type inside, then it is starting already to be more and more interesting. So what is going to happen if you use it with the person interface? persons. And I can, for example, add these. For example, I can say persons dot add, and we have to give the person interface now. Now this is more interesting. I can put a human that we've already tried. I can put a girl, for example, if I want, and it can cope with them. Now it can also push a guy if I want. A guy. Oh. So I added three different classes, different uh, objects that belong to different classes, and all of them belongs to this array list now. What I can do with them, for example, is I can create, I save it, and I can create in the person Java a new type of get average mass index. For example, I copy this one this time, and I put it at the top, and let's say we create a get average mass index for an array list of person interface. Array list of person interface. I use an underslash here, it's better, but as we can see, we still need the import here. Yeah, and well, let's see what we have got here. The persons dot size, that is what we need here. Instead, this float is going to be good. We can go through this way, I guess. Let's see. But I have to use a person interface here. Yes, I got the person interface, and I use the for cycle here, and I get the get body mass index, and everything works just like in the other situations. And what is important, and I could have done it also with the stack, as I told in the previous demo, that I can do it also with the stack to specify this type, to specify the type of the objects with the generic that I pass here. And this way I don't have to use this typecasting that I use here. So because this is just a general object that I get out of the stack here, because I didn't specify, but this time I specified it, so I get the person interface, and I don't have to use any typecast here. And it's already working. I saved it, okay. And if I come here and just say that this is static, so person dot get average mass index for array list persons, and I say persons. That's it. Persons. What's the big problem? Well, oh, this says it's a list, so I could have used a yes, I know, because this is declared to be a list, so this is an interface, and what I was doing here is I wrote array list here. So this way it would be better to use the interface as well here, because this is would be a higher level of abstraction here. So this way I can pass any object that belongs to any class that implements the list. So that way we can do it. Yeah, that's right. Oh, yeah, but it also gives a problem with the other one, because it will over yeah, because it also that stack also belongs to the list. Yes. Well, this time I don't need this anyway. I don't need this anyway. I don't want to show that, and I don't need this as well, so I can cut them out. I just didn't want to spend time on these things, so we can get it. And okay, UG mass index of persons list is okay. That's it. I save it. Okay, that's it. Run. AVG mass index of persons is this. So it's working for the array lists as well. Well, this is the way to create them and to use them. Uh, of course, there are lots of more methods that we can use. We can clear it, as I said, and we can get a specified person interface object uh, at an index, and we can remove as well. Remove the object or remove at an index. So I can say that if I have the object, I can remove it, for example. I will try this one just to show. Okay, let's do it like I say that there is for example, a guy, one guy who is going to be, I copied from here, I don't know, I copy Ben. This is going to be Ben. And for example, I add him also. Persons add, and I say one guy. Yes. Oh, the NetBeans helped me again. So he is added as well. But for example, if I just want to remove him, remove, and I can specify if I know the index of it. I say that 1, 2, 3 or something. Then it will remove the object from the specified index. I use the one guy. So I have it here. I have the instance, so I can catch it. I can get the guy. I can remove it. I can remove him. But first show that it is added. We cannot see the names because I didn't really write them, but we can see that the mass index is bigger because Ben is added also, and yes, he is 76 kilos, I think. Okay, but what happens if I remove him? What we will see now is that it's going to change back to the 90 because it's of course I can write the um, also the, for example, the person dot size, persons dot size, for example, or anything. I can write them out, or persons to string maybe would be also good. String representation of it. Oh no, sorry, but you can see that there is a human and a girl and a guy as well. So these, okay. Sorry, I should use a cycle for it. No matter. So basically, we have seen how to create list objects that belong to classes that simply implement the list interface. And we have seen working array lists and also stacks before in the previous chapter. We are going to see the classes under set and their usage now. What is a set? The set in Java language is very close to the mathematical set. It is equivalent to it in programming. This kind of collection doesn't allow us to duplicate elements. So it cannot contain duplicate elements. One element occurs only once. The interfaces that are under set and the classes that implement set are able to store elements this way. The Java platform includes three general set implementations: hash set, tree set, and linked hash set. As I mentioned, none of them can have duplicate elements. First, talk about the hash set. The hash set uses a hash table to store the elements. Well, the hash table uses value and key pairs. The keys are produced from the value. So it places the elements in the hash set by using a key which is unique. So this is the hash table. The linked hash set includes also a hash table and a linked list to preserve the insertion sequence. So the elements inside a linked hash set are linked. The tree set stores the elements in alphabet sequence. The elements in tree set are stored in a directory tree because if we want to search an element, it needs less steps to find it. How is it possible that the tree set orders the elements? This is possible because the objects which belong to tree set, the classes, must implement the comparable interface. And if you implement the comparable interface, then we have to implement the public int compare2 on the objects. So this way, the objects can be compared to each other. So for example, if we have two objects and we call compare2 on the first object with the parameter of the other object, we get a negative value if the first object was smaller than the other according to the natural sequence. We get 0 if the two objects equal, and we get a positive when the first is bigger than the other. So the object on which we called the compare2 is bigger than the object that is the parameter. Let's talk about the classes under map now. The map is an associative container. It stores key and value pairs. The key and the value that are belonging to each other are called together registration. Each key has to be unique. So this way we can reach the values through the keys. The collection stores the key and value pairs. There are two very important implementing classes of the map interface: the hash table and the hash map. They are close to each other. The difference is that the hash table is unsynchronized and it permits snooze. So these are very important classes. And what is also very important, there is a sub-interface called sorted map, and this kind of map provides an ordering on the keys. There should be a natural ordering on the keys, and to be able to do this, all keys that are inserted into a sorted map must implement the comparable interface. We will see a tree map class in our practical demo. These may seem a little bit complicated at the first sight, but in the practice they will be very clear and easy to use. So we can put our values in this kind of containers, and we have to give also a key to them. So these are the pairs that we are going to give to these maps. We are back here in the NetBeans IDE, and we are going to create an example on the map interface now. As you can see, I have cleared everything out here from the test project, from the main class, all the sample codes. This is because it was beginning to become a little bit messy out here, but I've kept the person, guy, girl, and the other Javas, so we can use them from now on, just like before, but the test codes have to be new. So I create a map here, and for the map I specify the generic types, just like the previous for the list, but I have to specify two here, and I specify an integer object here And what I specify is a person interface. The person interface object type. I call this our map. And this is going to be a new hash map. And for the hash map I specified also. So this way we can put these kinds of elements here and the rounded brackets because we are creating objects here. So this is going to be a map, and I have to put some data inside it, but I don't want to type so much, so I have cheated again, and I prepared some code here. I put it in the bottom of the other class to hide it. So I am prepared for this. So this way I put 4 guys inside of our map with new integers. This is a kind of class that uh, is going to give us integer object types. So this is the object representation of integer, and what I give here will be the value of it. So I use 4 1 3 2. This is important because they are not in order. So this is these are going to be the keys that we are going to use, but I put them so they are unique, as we have told. All of them is different, but they are not in order. What I will do some tricks. I create a set here, which is our map dot entry set. We get the entry set, so the elements get the mapping set interface to get these keys and the values together to the set now. And I use an iterator because I want to go through the elements by key. So I use an iterator. This is a special kind of object that will help us. And this time I use a while cycle to be able to go through this iterator. And it has a hasNext method, which gives us a boolean while we will go through this iterator, and we will use the next it.next inside. So that cycle will go while this it.hasNext gives us true back. And also there is a special thing that inside map entry, this is going to be an entry from the map, and what we're going to get back from here is it.next, as I've told. So the next element from this iterator. This iterator has the set that is created from our map. So we really used everything. I have to use a typecast here because we get it from the iterator. Well, this is not the easiest thing, but this is more advanced a little bit. And I use the integer typecast here because we are going to get from the map entry that we have the get key. So I get the key, and I know that this is an integer. So that's why with this way we are going to uh, get the key out of it. And I can use a simple integer here because the integer object can be given as a value to int. So this is an automatic typecast here. And no, this time I want to get, yes, this string is good. String is going to be good. String name, and we are going to get the name of the guy like this. I say that am dot get value. This way I get an object from the map entry. I have to use a type cast here. I typecast it to person interface because we have put person interfaces there. And after that, with this, I can say get name and just write it out that key and key and value and also value. Oh no, name. I use the name here. Well, this is the value in it. In fact, of course, it's just a part of the value. So this is only the name that belongs to the key, but I could use all the other informations as well. I just this is enough for us. Now I can see. Yes, the key one has the value Chuck. So we can see that the one is with Chuck, and so on and so on. The 2 is with Jack and John. So we get the keys in an order here, this way. Although I've put them unordered here. This is because I use the set here and an iterator. These are special objects. So this way I could show some kind of making of order, and also the creating entries with keys and values onto maps with generic types. We are going to do some practice on the sets now. This is going to be also interesting because I'm going to create to make some changes on our person Java. This is our class, and what I will do is also implement here something else, the comparable. This is because we want to give also order to our set. So I have to implement a comparable, and we create here the person just like before. And what we need to do to be able to implement the comparable is only to write a public int compare to person interface. I think I can use here person interface. I hope I can do it. Or maybe just object. Yeah. Okay. No, it's going to be good like this. And I say that if per dot get age is smaller than this dot get age, so that this is going to stand out for our object that called the compare to. So the object that we are calling the compare to on, and the per is the attribute here. So this way I can compare them, and if this is smaller, then return 1. And if, well, I copy this. If they are equal to each other, then I return 0. I return 0. And if none of these is going to happen, then I return -1. Now this is also showing a little bit tricky way of using ifs. As you can see, I don't use else here. I say because it's the return statement is going to end our method here. So if this statement is true, then it's finished. And so that's why I don't have to use else here. I can use else, I can write here else, but it's the same thing, because it comes here only if we didn't return 1. And if this is true, then we return 0. And if none of these happen, then we return -1. And this is equals if I wrote else here. Okay. And this way we already overridden compare to. And I guess that I could write an override annotation here. Sorry. Yeah, I should have used the object, I guess. I have to use the object O, and only I get here the person interface per, which is going to be the O, and I use a typecast. Oh, sorry. This is small. Okay. This way it's okay, because the signature was not the same. Sorry. So I have to use the same signature, of course, when I override one of the abstract methods from this interface. Okay. This way I already implemented the comparable interface. From now on I can use it, I guess. Okay. Um, okay. This is what we wrote previously. I'm going to create something else from it. I use a set now. I use a set, and it only contains a person interface. I see our set, and this is going to be a tree set. A tree set with this type. Okay. And to our set, I'm going to add these person interfaces. This is just quicker to do it this way. That's why I do it like this. So you can see sometimes copying is quick. Okay. So I added to our set this, and in fact, what I simply have to do is that get a force cycle, for example, and well, person interface per, and go through this hour set. So this way I can write out the what we have got here. Well, I say that just the per dot get name, we say that, for example, ban is, we add per dot get age, years old, and per dot get weight. I don't write out everything, this is the weight, kilos. So I write that this guy is the name, the age, the weight. But because we compare the ages here, indeed I really need to to use different ages. So the second is the age. So I shouldn't forget that. That's why I always change these when I create, because if I use the same numbers, then our outcome will not be very interesting. Yeah, John is 22 years old and 84.8 kilos. So it is ordered by the age. and we didn't really have to do anything else than just going through this tree set, because the tree set uh, gives us an ordered thing, even if we didn't really have to call it explicitly that we want order, because the tree set, when we put them and we add them, then the tree set creates an ordered kind of tree from these, and the order is a natural order that is given by this compare to. That's why I had to override it. So I have overridden the comparable interface. And that's how the program knows. That's how already the objects know that their own order, to be honest. So this tree set knows that it's going to get a person interface, and that's why it is created this way. So that is how to create an order. There is still one important part of the Java collections framework, and this is the one collection utility class. This class is the java.util.collections, and java.util.collections. This is a special class that contains static methods that can operate on or return collections. There are some polymorphic algorithms inside them. During programming, when we work on work with collections, we can simply just call some of these static methods on one of our collection or set, a map, or a list, for example. There are some empty collection creators, for example, to mention. Search methods, some ordering methods like sort. If we want to use them, there is a natural ordering implemented, and the elements must implement the comparable interface. There are some synchronized collection creators inside this class, and read-only collection creators. So there are many very useful methods that can be called from any Java that includes that imports the Java utility class in java.util.collections. We are here again on the website of Oracle, looking at the Java specification, API specification, because I think it's worth some time to look around here and see something about the collections and the collection class hierarchy, because it is a complex thing. The interfaces that and the sub-interfaces that implement them, and also the classes, lots of classes. So this is a kind of collection structure, the class hierarchy structure that that is more complex. And if we consider that there is a multiple inheritance between the interfaces as well. So this is better to have a closer look here where we can see everything. And as I've told, the collections are inside the java.util. And when we are here in the java.util, we can see the interfaces. As we can see, there is the collection interface. The root interface in the collection hierarchy. And we also can see the map, which we were talking about as well, an object that maps keys to values. This is the short description. Let's go inside the collection interface. This is an interface that gets the type of elements. That is what I've told, that this is a generic inside of the smaller and the bigger sign that will give us the type of the element. And there are the sub interfaces that we were talking about. We can see that there are more, of course, but we were talking about the list and the set so far. And we have seen the vector as well. We were talking about it. So we will see that the array list are the implementing classes. We can see that there are some general methods. These are the abstract methods that are inside of our interface. So any class that is going to implement this class, this interface, will have to implement these methods. There are mostly general purpose methods for collections, like clear, that removes all the elements from this collection. Or contains, it returns true if the collection contains the specified element for general objects. And things like that, the hash code that we have talked about. Return the hash code value for this collection is empty, returns true if the collection contains no elements, and so on and so on. So it's good to look around here. We can make an array, object array out of them. So this is it. Let's have a look in the list. This is also an interface, as we can see. Still we are talking about interfaces. The implementing class is the array list, for example, the vector and the stack, which we also were talking about. An ordered collection, also known as a sequence. So we can say that there are lots of informations also here available that we can check out, and also some details about the methods. But this, because this is an interface, so that's why these are the specifications, but what these methods has to do. So in the classes that will implement these. So in these classes. Well, just let's go into array list. This is the class. We can see that this is the class hierarchy of it, and it implements these interfaces. So one of them is the list, the collection, of course, and these. Resizable array implementation of the list interface. There are lots of useful information on it. constructors, we can see we can get all the informations that we use during our programming about them. Yes, ensure capacity, get, returns the element at the specified position at this list. This is an important, for example, index of, returns the index of this occurrence. So we have get an element here and it gets the index, as we can see. Remove an element from an index. Remove this element, the first occurrence of the element. So you can use them to access and modify the elements. This is about the array list. We can check them out as well. The others as well. We have here in the list, but we can check the set as well. This contains no duplicate elements, as I have already told. And these are the methods of it. Also remove and hash code in the set, for example, if we use it, or contains, returns true if the set contains a specified element, and so on and so on. Yeah, this interface models the mathematical set abstraction. And we were talking about the hash set and the tree set. Yes, they are here as well, so we can check it. What I wanted to show as well is if we have here in the package java.util that there's also an important class that we have to mention. This is a collections class. This is a class, and this is also part of the Java collection framework. And there are static methods that operate on or return collections. So we can use these from the Java util to cope with. These are polymorphic algorithms, as I've told. And as we can see, there are three fields: the list, the map, and the set inside of it. These are what we were talking about, these interfaces. And we can see that there's, for example, the binary search methods. We search the specified list for the specified object using the binary search algorithm. And we have seen that these elements have to extend the comparable. So that is how we can search, because we can compare them. And also there is the also important the sort. This sorts the elements. Sorts list, for example. We can have a closer look at it a little bit. And we have a longer description here about the sort as well. Sorts the specified list according to the order introduced by the specified comparator. So we have to specify a comparator. That's how we can make difference between the elements, so we can see which is comparable to the other, or how to compare them. So we have to specify a way for it. So there are lots of useful things here, and we will use them. Synchronized versions. Yeah. For example, if we have a list, this returns a synchronized thread-saved list from our list. So this way we can use it in a multi-thread program, for example. There are lots of and also unmodifiable sets and maps and lists that these cannot be modified later. So this is a special way of changing them into unmodifiable. So lots of useful things. So as I always say, it's worth the time to look around here and see what they can do indeed.